Dear friends, I myself, Dr. Bharat Parab, discussing exercise, and the topic is factor theorem in polynomials or factorization, part 2. We have seen part 1, now this is part 2. Okay, so fifth one in this, actually, we have seen from 1 to 4 of this exercise in part 1. So, this is start of part 2. So, I am starting with fifth one, factorize. First one in this, px equal to x cube minus 2x square minus x plus 2 by factor theorem. Okay, answer, copy down all this polynomial as px here. Okay, now factors of the constant term 2, this is a constant term 2 are plus minus 1 and plus minus 2. So we need to find 0 of the polynomial if at all it is in this. So we substitute 1 by 1 value plus 1 minus 1 plus 2 minus 2. So px, copying it as it is. Now p1, you know what is this? P1 is 1 cube minus 2 into 1 square minus 1 plus 2. So if you solve this, you get 0. So x minus 1 is factor of px. Okay. Now minus 1, p minus 1, this is same as copied down from here. So minus 1 cube minus 2 into minus 1 square minus to minus 1 plus 2. If you solve this, you get 0. So therefore, x plus 1 is factor of px. So we got two factors. Okay. Now testing it for plus 2 and minus 2. So p2 is 2 cube minus 2 into 2 square minus 2 plus 2. If we solve this, you get 8 minus 8 minus 2 plus 2 is 0. So therefore, x minus 2 is factor of px. Okay, very simple. And we are still testing it for minus 2. No need to check actually, because for the cube or the number of factors will be equal to the degree of the polynomial. Okay, so I'm still checking it. P of minus 2 is all this minus 2 cube minus 2 into minus 2 square minus 2 into minus 2 plus 2. So you get minus 8 and all this 2 into 8. So ultimately what you are getting is not equal to 0. So x plus 2 is not the factor of px. Okay, I think you can skip this in exam, but we have to find all this by this method. So the factors of the above polynomial px is, okay, these are x minus 1 into x minus 2 into x plus 1. Now I'm taking it in this way, x minus 1 first one, then x plus 1 second one, and x minus 2. Okay, anyway, that is also correct. Factorizing same polynomial by another method, splitting middle terms method. Okay, so we are directly going for the answer. Px equal to this polynomial, copied down as it is. Now whenever you find the polynomial with degree more than 2, we have to use factor theorem. Okay, till you reduce this to 2 degree, then after that you can see the splitting middle term method. Okay, you will come to know after solving some problems. Okay, so look at these factors of constant. These two are plus minus 1 and plus minus 2. We have seen this in previous slide. Okay, so p1 is 1 cube minus 2 into 1 square minus 1 plus 2. You are getting at 0. So x minus 1 is factor of px. Now we have to take advantage of this. Okay, and split the terms like this. See, it's written like this. Now you are splitting the terms so that you get x minus 1 common. So x cube minus x square, remember this. So if you take x square common, then you will get x minus 1. Okay, got it. Now remaining minus x square. Now this is here. Now 2 is again splitted as plus 1 here and plus 1 here. Okay, so look at it, how you have to split it very intelligently. Okay, so it is written like this. X is written here, 2 is here, that is one of the 2 is here and 1 is here. Okay, this is accompanying this. Okay, so I am taking x square common, and in bracket you are left with x minus 1. Now just see, I am taking minus sign common of all this. Okay, so we are left with x square minus 1. This sign will change. One bracket plus, this is gone here. So this is plus and this will be minus. So x minus 1. Okay, got it? See it very carefully. Now I am going to factorize this part. Okay, so you copy it as it is. Now come here, minus sign, big bracket. This is x minus 1 and x plus 1 plus x minus 1. Got it? See this color change. Okay, this into this, and this is plus x minus 1. Now I am taking x minus 1 common from this bracket. Remember, okay? So copying till here as it is, and x minus 1 common, and what you are left with in the bracket is x, okay, plus 1, and this is plus 1. So it is x plus 2. Okay. Now from the whole thing, I am taking x minus 1 common here and here. So I am taking x minus 1 common, and you are left with x square minus x plus 2. That is equal to x minus 1 and into the bracket x square minus x minus 2. Okay, very simple. Now you have to find it like this. See, split it. X minus 1 is common, so into the big bracket x square minus 2x plus x minus 2. You know this. Okay, so this is common, so you take x common, so x minus 2 plus x minus 2. Now take x minus 2 common from here, and you are left with x minus 1, x minus 2, and into this bracket x plus 1. Okay, try it yourself on the paper, and you will find it is very easy. So ultimately factors are same, uh, x minus 1, x plus 1, and x minus 2. Okay, it's very simple. Second example, the second polynomial px equal to x cube minus 3x square minus 9x minus 5. To factorize this by factor theorem. Okay, the answer, see, try to study very carefully, because there is some hint in it, and that is very useful for you in the exam. Okay, so answer px equal to all this polynomial, then last term, you see we wrote it here. Factors of constant term minus 5 are. We have to concentrate only on last term minus 5. So factors of this term minus 5 are plus minus 1 and plus minus 5. And we have to substitute these all these values, 4 values, and check for the 0 of the polynomial. So you are substituting one by one. So P1 is 1 cube minus 3 into 1 square minus 9 into 1 minus 5. So if you solve this, you don't get 0. So x minus 1 is not a factor of px. Okay. Now checking for p minus 1. So substituting minus 1 in place of x. So minus 1 cube minus 3 into minus 1 square minus 9 into minus 1 minus 5. So if you solve this, you get minus 1 minus 3 plus 9 minus 5 is 0. So x plus 1 is factor of px. Very simple. Now substituting plus 5. So p5 is 5 cube minus 3 into 5 square minus 9 into 5 minus 5. So you solve this, you get 125 minus 3 into 25 minus 45 minus 5. So ultimately you get 125 minus 75 minus 45 minus 5. That is 0. Okay. So x minus 5 is factor of this. Okay. Now we should have three factors, because it is cube polynomial, or degree of this polynomial is 3. So there will be three factors. We are getting only 2. So we have to check for minus 5 also. So checking for minus 5, p minus 5, you're getting minus 5 cube minus 3 into minus 5 square minus 9 into minus 5 minus 5. So if you solve this, you don't get 0. So x plus 1 is not a factor of px. That means any one of these, there are only two factors we are getting, and there has to be three factors. Okay, so one is repeating. It is very easy to see or check or guess which is repeating, because last term is -5. We are getting -5. So if you multiply this -5 with 1, you get -5, and again with 1, then only you get -5. Okay, so this is repeating. So the factors are x plus 1, okay, into this bracket, another bracket x plus 1, okay, and last bracket x minus 5. These are the factors. Okay, it's very easy. Still, if you face any difficulty, write to me in the comment section and I will help you how to solve this. Okay, so same polynomial, now solving this polynomial or factorizing this by splitting middle terms. Okay, so answer, we have to write the whole polynomial as it is, and we have to use the factor theorem in the beginning. So I'm using it, factors of the constant term. You know the start of the factor theorem. You have to check for the constant term and check the factors of the constant term, which are plus minus 1 and plus minus 5 in this case. Okay, so Px, we have to substitute all these values to check for the 0 of the polynomial. We know that. So P1 is 1 cube minus 3 into 1 square minus 9 into 1 minus 5. Okay. So if you solve all this, you don't get 0. So x minus 1 is not a factor of Px. We have seen this earlier also. Okay. So now checking for minus 1. So P minus 1 is minus 1 cube minus 3 into minus 1 square minus 9 into minus 1 minus 5. So you solve this, you get 0. So x plus 1 is factor of Px. Now keeping this x plus 1 is factor of this polynomial, you have to split this in such a way that you get x plus 1. So see how I am splitting it. X cube, now see minus 3x square is to be plated as x square minus 4x square. Okay, because you have to have x plus 1 as a factor. Okay, you will get it here. Now this minus 4x square minus 4x, okay, and the remaining 5x, that is minus 5x, are written here. Okay, and minus 5 is very easy. Now take x square common in this these two terms, and you are left with x plus 1 in this. Now minus 4x, you get x plus 1, and minus 5, you get x plus 1. Now you take x plus 1 common from all these, and in bracket, big bracket, you are left with x square minus 4x minus 5. Okay, so or do it on paper, then you will understand it in better manner. So now split this. Okay, so keep this copying like this. Okay, and now concentrate only on this bracket. So x square minus 5x plus x minus 5. Okay, so this minus 4x is to be written as minus 5x plus x. Now take x common in this, you are left with x minus 5, and put a bracket to this x minus 5, and now take x minus 5 common from this, you get x minus 5, and into the big bracket you are left with x plus 1. Okay, this is 1 here. Okay, so ultimately the factors are x plus 1, x minus 5, and x plus 1, again same as in the previous case. Okay, very simple. Now factorizing of the same polynomial by a remainder theorem. Okay, so we will see this. The answer, px equal to x cube minus 3x square minus 9x minus 5, copied down as it is, and we are trying to find one factor at least by the factor theorem. Okay, so we start with this. So the factors of constant term minus 5 are plus minus 1 and plus minus 5. Okay, we have seen this even before. So we substitute 1 and minus 1 plus 5 and minus 5. Okay, in this to find the 0 of the polynomial. So p1 equal to 1 cube minus 3 into 1 square minus 9 into 1 minus 5. If you solve this, it doesn't uh, ends in 0. So x minus 1 is not the factor of px. Okay, so try for x equal to minus 1. So p minus 1 is minus 1 cube minus 3 into minus 1 square minus 9 into minus 1 minus 5. Okay, if you solve this, you get 0. So x plus 1 is factor of px. So we should have at least one factor so that we can divide the polynomial with this, okay, by the remainder theorem and proceed further. Okay, so we divide px, that is this by x plus 1, and this is carried on the next slide. Okay. So division continues. We have to divide this by x plus 1. So writing it like this, we are familiar with this. We have seen in some other video also. Can refer that also. So writing the whole thing. First step is write the polynomial in decreasing order of degree. It is already there, so I have written it. Okay. And x plus 1 here. Then we know the second step. Okay. So x cube upon x is x square. I write it here. X square into x is x cube, and x square into 1 is x square. Now change the sign and this get cancels, and minus 3x square minus x square is minus 4x square. Copy the whole thing as it is. Now repeat the second step here. Okay. So minus 4x square upon x is minus 4x. Remember this here. Okay. Write it here. So minus 4x into x is minus 4x square. See the sign is on the upper side. Okay. And minus 4x into 1 is minus 4x. It is here. So you have to change the sign. First plus minus here, it is minus plus here. Okay. It cancels, and we are left with minus 9x plus 4x is minus 5x. This minus 5 carries. Okay. Now we are repeating this step again. Minus 5x upon x is minus 5. Write it here. So minus 5x into x is minus 5x, and minus 5 into 1 is minus 5. See, it is here. So changing sign, this cancels everything and you get 0. Okay. So as this is the factor, you are getting 0. So we are getting, this is another factor. Okay. So see, this is not an end. So we have to still find the factors of this. Okay. So x plus 1 into this, we know this. Okay. This into this plus this, we know that. Okay. Now factorizing this part here, we know this, we have done this. Okay. X square minus 5x plus x minus 5. I am writing minus 4x as minus 5x plus x, and then taking x common in this, I am left with x minus 5, and 1 common, get x minus 5. Okay. So now x minus 5 is to be taken common, and in the bracket we are left with x plus 1. Okay. So we have done this part in some other example also. This is very easy. So this is the way how you have to use a remainder theorem. Okay. So it is very easy. So the factorization continues, and the polynomial changes. Now this time px equal to x cube plus 13x square plus 32x plus 20 by factor theorem. Okay. Answer, write the whole polynomial as it is. Okay. And start factor theorem. So first time is we have to see the factors of this. So factors of 20 are plus minus 1 plus minus 2 plus minus 4 plus minus 5 and plus minus 10. Okay. Now if you use simple logics, it is given here all the terms are positive, so positive factors will not give you 0. Okay, very simple logic is given here. So we will try minus factors, negative factors. Okay, so p minus 1 is minus 1 cube plus 13 into minus 1 square plus 32 into minus 1 plus 20. If we solve this, you get minus 1 plus 13 minus 32 plus 20 is 0. So very lucky to get a factor. X plus 1 is a factor of this. So we will try for again minus 2. Okay, so p minus 2 is minus 2 cube plus 13 into minus 2 square plus 32 into minus 2 plus 20. If we solve this, we get minus 8 plus 52 minus 64 plus 20, and we are ending with minus 72 plus 72, that is 0. Very lucky to find two factors out of three factors, because this will have three factors. If this is cube or degree of the polynomial is 3, so we immediately got two factors, x plus 1 and x plus 2, both are factors. Okay, we have no way out, we have to try all these. Okay, there will be some factor or the other. Okay, so we are trying for x equal to minus 4. So p minus 4 equal to minus 4 cube plus 13 into minus 4 square plus 32 into minus 4 plus 20. And if we solve this, it doesn't end in 0. So x plus 4 is not a factor of px. Okay, that is how we have to proceed every time. The same problem continues. I have copied it down so that you don't have to go back and check. Okay, so we have seen for minus 4, minus 2 and minus 4. Now checking for minus 5 and minus 10. So coming here directly, p of minus 5 is minus 5 cube plus 13 into minus 5 square plus 32 into minus 5 plus 20. Okay, So if you solve this, you get minus 125 plus 13 into 25 minus 32 into 5 plus 20. So ultimately you get a minus 285 plus 345, which is not equal to 0. We are not interested in addition. Okay, we have to see only whether it is 0 or not. Okay, so it's not equal to 0, so x plus 5 is not a factor of px. Okay, now checking for 10 minus 10. Okay, so p of minus 10 is minus 10 cube plus 13 into minus 10 square plus 32 into minus 10 plus 20. So this is minus 1000 minus 1000. Remember the sign. Okay, plus 13 into 100 minus 30, this sign comes out, 32 into 10 plus 20, and we get minus 1000 plus 1300 minus 320 plus 20, and you are getting minus 1320 plus 1320, that is 0. Okay, so x plus 10 is a factor of px, though it is very little bit lengthy. Okay, because we have to substitute all these factors. Okay, but you could solve it. So x plus 1 in one bracket, x plus 2 in another bracket, and x plus 10 in third bracket. These are the factors of these polynomials. Okay. Now factorizing by using another method, splitting middle terms. Okay. So initially we have to use a factor theorem. So answer, write the whole polynomial and use factor theorem. So we continue, plus 20 is last term, and the factors of this 20 are plus minus 1 plus minus 2 plus minus 4 plus minus 5 plus minus 10. So we know, we have seen that positive values are of no use for us, so we are using negative values. So p minus 1 is equal to minus 1 cube plus 13 into minus 1 square plus 32 into minus 1 plus 20. We have seen this. Okay, so this comes out to be 0. So x plus 1 is factor of px. So now keeping this x plus 1 in mind, we have to split this in such a manner. Just see how I have done it. So this is the polynomial. So splitting this, we look at the 13. Okay, so x cube plus this 13x square is to be split as 1x square plus 12x square, and 32 should be 12x plus 20x, and this 20 carries as it is. Okay, so that you take x square common and you are left with x plus 1, plus 12x common, you are left with x plus 1, and 20 common, so x plus 1. Now you can take x plus 1 common. Why we are trying to see this, okay, or do this, is because x plus 1 is one of the factor and that we have found out. Okay, so x plus 1 taking common into the bracket, you get x square plus 12x plus 20. Now split this. Okay, so x plus 1 and into bracket x square plus 10x plus 2x plus 20. Okay, you know how to do this. So now taking, I'm copying this as it is and taking x common, so x plus 10, and 2 common, so x plus 10, and taking x plus 10 common, so we get x plus 1 as it is, and into another bracket x plus 10 and x plus 2 remains in the bracket. Okay, so factors of this polynomial are x plus 1, one bracket, x plus 2, and x plus 10. Okay, now finding the factors of this same polynomial by remainder theorem. So we know even in the remainder theorem we have to proceed with a factor theorem and to find at least one factor in the beginning. We have done this. We have been doing it for last two methods. So I am repeating it again. X plus 1 is one of the factor, and we have to divide this by this to get another factor. Okay, so that is on the next slide. Okay, so solution continues. We have found one factor, so we have to divide this polynomial by this to get another factor. We have seen this. Okay, so here write the polynomial in decreasing order of degree. It is already there, so we have written it here. And x plus 1, so x cube upon x, you know what is this? So it's x square, so x square into x is x cube, and x square into 1 is x square. Change the sign, these and this cancels. Okay, so 13x square minus x square is 12x square, and copy all this like this. 12x square upon x, it is here, equal to 12x, write it here. 12x into x is 12x square, and 12x into 1 is 12x, so change the sign. This cancels with this, and you are left with 32x minus 12x is 20x. Carry this 20, And again same thing, 20x upon x is 20, write it here. 20 into x is 20x, 20 to 1 is 20, change the sign, and the remainder is 0. Okay, so the factors are x plus 1 and this x square plus 12x plus 20. So I'm taking this here. So factors are x plus 1 and this we have to split this. So x plus 1 into the bracket x square plus 10x plus 12, 2x plus 20. So 12x is to be split it like this. Okay, 10x plus 2x, and now taking x common in this, get x plus 10, and 2 common in this, you get x plus 10, and now taking x plus 10 common in the whole bracket, you get x plus 10 into the bracket x plus 2. So factors are x plus 1 into x plus 10 into x plus 2. Okay, same. So factorize fourth last one, py equal to 2y cube plus y square minus 2y minus 1. Factorize this by factor theorem. Okay. So answer py, copy all this. Okay. Factor of the constant term minus 2. Minus 2. Remember this. The constant term is minus 1. Okay. But coefficient of first term y cube is 2. So we have to multiply this constant term by 2. Okay. So 2 into minus 1 is minus 2. Hence the constant term is minus 2. And the factors of these are plus minus 1 and plus minus 2. Or if you want this coefficient to be 1, then we have to divide the whole polynomial by 2 and multiply by 2. Okay, so factors of coefficient of y cube, which is 2, are to be taken as plus minus 1. That means we have to divide by 2 and then multiply the factors by 2. Okay, so in general, if coefficient is a, then factors will be plus minus a. This is same as this, a, and then multiply the factors by a to whole this. Okay. Now, if to see the 0 of the polynomial, okay, so y cube coefficient has to be 1. So that's why we divide this by 2 and multiply the whole thing by 2. Okay, that is what is the meaning of this sentence. Okay, so py equal to all this. So we are checking for plus minus 1 plus minus 2. So p1 is 2 into 1 cube plus 1 square minus 2 into 1 minus 1. So if you solve this, you get 0. So y minus 1 is factor of py. Okay, now for minus 1. So p minus 1 is 2 into minus 1 cube plus minus 1 square minus 2 into minus 1 and minus 1. Okay, so if you solve this, you get 2 into minus 1 plus 1 plus 2 minus 1 is 0. So y plus 1 is factor of this. That is also factor. Okay, we got two factors. Okay, and now we have to substitute by plus 2 and minus 2. So we're checking for 2. There will be three factors. Okay, so P2 is 2 into 2 cube plus 2 square minus 2 into 2 minus 1. So if you solve this, 2 into 8 plus 4 minus 4 minus 1 is not equal to 0. So y minus 2 is not a factor of py. Okay, now we will check for minus 2. The solution for the same polynomial continues till here. It was just a copy of last slide. Okay, we were trying to substitute minus 2. So p of minus 2 equal to 2 into minus 2 cube plus minus 2 square minus 2 into minus 2 minus 1. So 2 into minus 8 plus 4 minus 1 is not equal to 0. So y plus 2 is not factor of py. Okay, so all these values are over. We got only two factors. Okay, now we know the coefficient of y cube is 2 and we want this 1 here. So we divide the whole polynomial by 2. Okay, by this number or this coefficient. Okay, if it is a, we have to divide it by a, and the last term will be plus minus 1 upon a. In this case, it will be plus minus 1 upon 2. So these are also the factors. Okay, so as shown, see it is given here. So plus minus 1, we have to check for this also, because this is a constant term or last term if we divide this by 2. Okay, remember that whenever you get this term not equal to 1, then we have to follow all these steps. Okay, so I'm doing it here. p of half equal to 2 into 1 upon 2 whole cube plus 1 upon 2 the whole square minus 2 into half minus 1. If you solve this, you get 2 into 1 upon 8 plus 1 upon 4 minus 1 minus 1. So 1 upon 4, this cancels, plus 1 upon 4 minus 1 minus 1 is not equal to 0. So y minus half is not factor of py. Okay, the all others remain same, only we have to think of this. Okay, so the same problem continues. Okay, now p of minus half, so p minus half equal to 2 into minus 1 upon 2 cube plus minus 1 upon 2 square minus 2 into minus 1 upon 2 minus 1. If you solve this, you get 2 into minus 1 upon 8 plus 1 upon 4 plus 1 minus 1. So this will be minus 1 upon 4 plus 1 upon 4 plus 1 minus 1 comes out to be 0. So y plus 1 upon 2 is factor provided you multiply the whole by 2, because this whole thing is divided by 2 and multiplied by 2. And because you divide by 2, you are getting constant term as minus half. Okay, when this is also multiplied by 2. Okay, so we have to carry this 2 for further. Okay, now see, the factors are y minus 1, y plus 1, and y plus 1 upon 2 into 2. Okay, so don't forget this 2. Okay, now taking LCM of this, okay, you get 2y plus 1. I'm not writing that 2 because this 2 will cancel with this. Is here. This 2 will cancel with this. Do it yourself. You will find it very easy. So the final factors are y minus 1, y plus 1, and 2y plus 1. Okay. So these are your factors. That is how you have to tackle this. Okay. So now factorize the same polynomial by splitting middle terms. Okay. Answer py equal to all this. Okay. Now try to find the 0 of this polynomial. Okay. So for finding this, we have to use factor theorem, and for factor theorem, we need this term coefficient to be 1. And to make the coefficient of this term 1, we have to divide the whole polynomial by 2 and hence multiply by 2, so that we are not changing any value. Okay. So if we have to carry this 2 ahead. Okay, we will see this. We have seen this, of course. So if you divide this by 2, then the last term will be minus 1 upon 2. Okay, and the factors of minus 1 upon 2 here are plus minus 1 and plus minus half. Okay, so we have seen this part in earlier example. Okay, so now we are substituting all these values to get at least one factor. So I'm substituting 1. So p1 will be 2 into 1 cube plus 1 square minus 2 into 1 minus 1. And if you solve this, you get plus 2 plus 1 minus 2 minus 1 and 0. That is the value of all this is 0. So therefore y minus 1 is factor of py. Okay, now as we have one factor, so now we will be using middle term splitting method. Okay, so keeping this in mind, we have to rearrange these terms or split these terms rather, so that you get y minus 1 as a factor. So see here, 2y cube, I am taking this y square as minus 2y square plus 3y square. Okay, so I am writing this y square as minus 2y square in the beginning, because so that I can take 2y square common, and in the bracket I will be getting y minus 1. Okay, so that is how we have to use this technique, and we are not changing any value. So minus 2y square plus 3y square is y square. Now here, let's see, this 2 minus 2y is to be written as minus 3y plus y. Okay, so that I can take 3y common, and we will be left with y minus 1. Okay, and here it is y minus 1. Okay, because y minus 1 is a factor, this is going to happen. Okay, so I am taking 2y square common and left with y minus 1 in the bracket plus 3y into y minus 1 and y minus 1. Now taking y minus 1 common from all this, I am left with 2y square plus 3y plus 1. Now it is very easy. we have to split this only. Concentrate only on this and copy this as it is. So 2y square plus, see in the bracket only, okay, 2y square plus 2y plus y plus 1. So see here, taking 2y common and left with y plus 1, and this is y plus 1. Now taking y plus 1 common from this bracket, this is carried as it is, so y minus 1 in one bracket, y plus 1 in another, and we are left with 2y plus 1 in this. Okay, these are the factors. Okay, so the factors are y minus 1, y plus 1, and 2y plus 1. Okay, now same polynomial by remainder method, I am trying to solve all these problems by all the methods so that you are acquainted with all these methods. Okay, now remainder theorem. Okay, so answer, so py, write all this. Okay, and for this we need at least one factor so that we can divide that and find the other. Okay, so I'm taking this as it is. Okay, the factors of the constant term minus 2, this into this is minus 2 or plus minus 1 and plus minus 2, we have seen this. Okay, and we have seen all this. Okay, and substitute plus 1 minus 1 plus 2 minus 2. So I am doing it here. P1 equal to 2 into 1 cube plus 1 square minus 2 into 1 minus 1. And ultimately we know we are getting 0. So y minus 1 is factor of Py. Okay. Now we have to divide this by y minus 1 by remainder theorem and get other factors. Okay. So this is given on the next slide. Okay. So the factorization of this polynomial by a remainder theorem continues. For this, we should have at least one factor, and it is here we have found it by a factor theorem. Okay, so y minus 1 is one of the factor. Okay, now we proceed in this way. Step 1, write the polynomial in decreasing order of degree. So it is already there. Okay, so you have written it. Don't waste time in writing this statement. Okay, if you write, it will definitely impress the examiner. Okay, but don't waste time, only type permits, then only you write it. Okay, so this is here, and y minus 1. Now come to this step. 2y cube upon y is 2y square, to be written here. 2y square into y is 2y cube, and 2y square into minus 1 is minus 2y square. Check the signs. Okay, plus minus and minus plus. Okay, we have changed the sign also, and this cancels, and you are left with y square plus 2y square is 3y square, and copy all this as it is. Okay, now 3y square upon y equal to 3y. So write it here. 3y into y is 3y square, and 3y into minus 1 is minus 3y. Okay, so change the sign, this cancels, and you are left with minus 2y plus 3y is y minus 1. Okay, and now y upon y is 1, so is here 1 into y is y, and 1 into minus 1 is minus 1. So change the sign, and everything gets cancelled, and remainder is 0. Okay, so this is one factor, and this is another factor. We will again try to split this. Okay, and see the factors lying in this. So we have taken it here. So this equals y minus 1 into the this answer. Okay, that comes, we are carrying out this y minus 1 as it is. Okay, and concentrate only on this bracket. Okay, so 2y square plus 2y plus y plus 1. So taking 2y common, y plus 1 plus y plus 1. Now y plus 1 common, we have seen this even before. So you are copying this y minus 1 as it is into y plus 1 into the bracket 2y plus 1. These are the factors we have seen. Okay. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of exercise of the factor theorem in polynomials or factorization, part 2, we have two parts for this. We have seen part 1, now this is part 2. If you have any difficulty, let me know through comment section and I shall solve it. Please like, share and subscribe. Thanking you. Good luck.